Featured in this video is a 6-year-old Dolphin Triton pool vacuum cleaner by Maytronics. It has a fixed 3-hour cleaning cycle. The frequency of usage is ranging from 1 to 3 times a week and is stored in the garage after each use. Lately, we noticed that it is prematurely stopping at random and we have to cycle the power to resume operation. Until it just doesn't move anymore. On the initial startup, the impeller motor is spinning but the drive motor is stopping after a short run. It seems that the drive motor is weak and requires a little push only to stop again and again. Out of curiosity, I removed the motor assembly and took it apart. There is no sign of a water leak inside the assembly. The PCB does not have a conformal coating, just a bag of desiccant stashed inside. There are no visible signs of burn marks or corrosion. If you have gone this far, always remember to take pictures prior to disconnecting the wires and removing parts. This is the controller board and the only circuit board inside the motor assembly. Wish I can perform a bench test on this controller, but hey, I am just a pool owner. The Triton model has 2 brushed DC motors, the impeller motor, and the drive motor. In this case, the impeller motor must go out of the way in order to remove the drive motor. Open the impeller motor from the end cap while leaving the top part undisturbed to rule out the possibility of water leaking. To remove the carbon brush from the impeller motor, push in the tab on the wire connector while gently pushing it down. You may have to cut the cable tie to give some slack on the wires. Remove the 2 screws at the end cap to open the motor. Replacing the carbon brush alone is not good enough. It is ideal to clean the end cap and the commutator from carbon dust deposits. Keep an eye on the steel wave washer at the end cap. Since there is about 50% or more life left on this brush, it is important to reinstall them back in the same orientation in order to minimize wear. Should you need a replacement brush, please do your own research. Now on to the drive motor. I use a 12-inch adjustable wrench to remove the drive motor from the casing. Access the gear by removing the 4 black screws. Inspect the gears for possible damage or clean them if necessary. Be careful not to lose the tiny nylon washer. As you may have noticed, the end cap is heavily soiled with carbon dust. I cleaned the end cap and made sure that the carbon brush can move freely. There's plenty of life left on the brush and there is no need for a replacement. Again, it is very important to clean and remove the carbon deposits between the contact bars of the commutator. Gently run a thin knife or blade along the slits and use fine grit sandpaper to clean the commutator. I reassembled everything back in reverse order and performed yet another bench test. I am not suggesting that this is the proper way to bench test a pool vacuum cleaner. In fact, I have no way of knowing what the proper procedure would be. But it is very important to take into consideration the position of the motor assembly. In this example, I am measuring 16 to 16.8 volts DC supply to the impeller motor while the position sensor assumed climbing the wall in the reverse direction, which is not possible in this model. Anyway, the impeller motor should run only in a counterclockwise direction when viewed from the top. The speed is variable and determined by the microcontroller. Under normal operation, the impeller motor must draw a predetermined amount of electrical current. Without the load on the motor, the controller will shut down by itself. Meaning, the assembly must submerge under water with the propeller attached. This is not a flaw by design but a safety feature. The voltage reading of 17.7 volts DC shown here is measured from the drive motor while running in the reverse direction, and then switched to the forward direction with minus 17.7 volts DC. This time, the drive motor runs with plenty of torque and no way to stop it by hand. Compared prior to the teardown, that's a good sign. Now you are about to see how the Triton model should behave when the motor assembly assumed the normal vertical position and the impeller motor has no load. As observed, the controller suspends the operation shortly after the initial startup as it should. At this point, all I have to do is to reassemble everything back together and drop it in the water. Be generous in applying the Teflon-based magic lube. You don't want any amount of water to leak inside the motor assembly. Remember, water will destroy the electronics. Use your common sense. And this is how a known good working Dolphin Triton pool cleaner should behave during the initial startup when submerged in the pool. So far, so good. It is now running on its second cleaning cycle since the repair. I can conclude that cleaning the commutator of the drive motor from excessive carbon dust has solved the problem. Thank you for watching.